we are ready to embark on Unit 2, which is quite frankly one of the most difficult units you're going to have during the course of the year, Ella. And the reason why we are covering it so early is because it lays a lot of foundation, right, for algebra and how things interact with each other that we'll be using as we go further. Okay, so Unit 1, I talked about it kind of being a smattering of review and new stuff. This is going to be mostly new. You've probably not done a whole lot with zero powers before. You know what a power is. You've squared things, you've cubed things. We talked about the order of operations. But how often have you seen a zero power? Maybe not so often. How about negative powers? Okay, if you kind of look at I should use things here. If you look at the homework that you've got coming up in Unit 2, it's probably things that you are unfamiliar with. Starting with CO10. Take a look at that stuff. What's that about? Okay, you go all the way down to PO9, and look what we're doing here. Right? So this is very algebra heavy. Because a lot of algebra, we talked about this, is relationships. How do things interact with each other? So Unit 2 is definitely a unit you don't want to get behind on. It's definitely a unit that is going to challenge some of you. But come out the other side of it, and you are going to be so algebra ready that no expression will scare you. Yes?
Are we allowed to use our calculator?
You will be able to use your calculator on the entirety of the Unit 2 test, yes. Okay. So we have some definitions to kind of tackle first here. And the objective is I can write and evaluate expressions with exponents in standard and expanded form. Okay. Standard form is when you see a power such as 2n to the fifth, right? That's kind of the standard form. It's got the power. Expanded form would be what is it actually telling you to do? What does it actually mean? So to get there, we're going to look at the parts of an exponent expression. What is an exponent or a power? What does it do? That's that little number, right, next to another number or a variable. What does an exponent mean? What does n to the fourth mean?
N times 4.
No.
N times n times n.
N times n times n times n, right? N times n times n times n. What if we had 5 squared? What does 5 squared mean? Not what the answer is, but what does it mean, Aiden? 5 times 5.
5 times 2.
Okay, not 5 times 2. No, you're going to send me to my grave if you multiply 5 times 2 in power. So think about this, okay? The first operation that you learned when you were a little youngster was addition, right? And if you were adding, say, 4 plus 4 plus 4 plus 4 plus 4, right? When math was first being discovered and written down things, people thought, gosh, that's a lot to write out. So what operation did they kind of come up with? Multiplication. Multiplication, as you learned in third grade, is just repeated addition. Rather than writing 4 plus 4 plus 4 plus 4 plus 4, we can just write 4 times 5. It means the same thing, right? Exponents are just another way to write repeated multiplication. Rather than writing out n times n times n times n, it's n to the fourth. Rather than writing out 5 times 5, it's 5 squared. So at its core, what an exponent or a power does, and this is the definition I want to leave you with, it's repeated multiplication. Just like multiplication is repeated addition, exponents are repeated multiplication. It's an easier way to write n times n times n times n or 5 times 5. Okay? Questions so far? Got the basics of it. Repeated multiplication. Should I repeat that?
Yeah, sure.
Repeated. Okay. The base of an exponent expression is what, and it can be a number or variable. The power is attached to. Okay, so it's what, and it can be a number or variable, the power is attached to. Number or variable, the power is attached to. Yeah, I was once told that my alphabet has like 250 letters in it because I combine a lot of letters to make one letter. That's the letter the over there. Okay. So for example, in our above expression n to the fourth, what is the base there? The n. Okay, that's what the power is attached to. In our other example, 5 squared, what is the base there? It is the 5, right? The base can be a number, it can be a variable, but it's what is being multiplied repeatedly. Okay? A coefficient is a number before the base, and here's the kicker, that is not affected by the power. Okay? A coefficient is a number before the base that is not affected by the power. I'll explain why that is in just a little bit. You got it. Most of what we say, I'll explain in a little bit, comes back to order of operations. This is one of those cases here. Okay, we'll just do the first example down here, 2n to the fifth. It kind of encompasses all of these things here. So in 2n to the fifth, we can see the power, right? That's the 5 there. The base, what the power is attached to, that's going to be the n. But that 2 out there, the 2 is the coefficient. Okay? It's the number that comes before the base that's not affected by the power. And as Chance just said, the reason why it's not affected is because of order of operations. What operation is between the 2 and the n there? Even though it's not written, we're multiplying. 2 times n to the fifth. According to the order of operations, what gets done first? The exponent or the multiplying? The exponent. Right? So if we were to write this 2n to the fifth in what's called expanded form, write it out, it's not going to be 2n times 2n times 2n times 2n times 2n. There's only going to be 1, 2, and then 5 n's. Right? This is 2n to the fifth in expanded form looks like that. 1, 2, and then n times n times n times n times n. Okay? So essentially, expanded form is the expression written out, written as repeated multiplication. Written as repeated multiplication. Just written out. Expanded, right? Okay. There's your crash course on exponent expressions. Any questions that you folks have? Easy peasy?
No.
Oh.
Wait, oh. For a second, it says 1.
Okay.
It's 1 page.
So let's do a few together here. Yeah, you've done expanded form before, but what? So this is a kind of a review. It's why it's a PO, because if you don't understand expanded form, Unit 2 is going to be difficult. Okay, it all starts here, right? So you've seen this type of stuff before. You may not have named it necessarily, but you've seen expanded form before, or you should have anyway. Okay, if you haven't, then we're covering it out. So there you go. But let's do a couple together. It says for each term, identify the coefficient, the base, and the exponent. I'm going to underline the coefficient in black. Actually, no, let's not use that because I don't want to blend in with the text. The coefficient in red, the base can be in green, and the exponent can be in blue. Then it says write each term as an expression in expanded form, and then finally evaluate the term when n equals 2 when applicable. Okay, not all expressions have an n, right? So in this first one, we already kind of talked about this. The 2 is our coefficient. And you might need to write these out in word form if you don't have fancy colors like I have up here. A box, a circle, triangle, underline, great stuff. Whatever helps you understand what the different pieces are. And then in expanded form, we already did this above, but it's 2 times n times n times n times n times n. And then it says evaluate the term when n equals 2. So if n is 2, we're just replacing all these n's with 2's.
You have to write that out.
Right? Yes. I know it's painful, but if I have to do it in my advanced age, then you can do it as well. And what do we get? What is 2 times 2 times 2 times 2 times 2 times 2? 64 is correct. Okay. Negative 10n cubed, same kind of setup as this one. What is the coefficient here? What is the coefficient? Negative 10. It's that number that comes before the base. Speaking of the base, what is the base? N. And we know that because it's what the exponent is attached to. And speaking of the exponent, what's the exponent? 3. Right? So there we have all of our pieces. And then in expanded form, what's this going to look like? Write it out for me, Aiden.
Negative 10 times 2 times 2 times 2.
So start out with negative 10 times n times n times n, right? But yes, then replacing that n with 2. Negative 10 times 2 times 2 times 2.
Wait, 2.
So evaluate the term when n is 2. So we have those n's there. We're replacing it with 2. The first one may be kind of tricky because the coefficient was also 2, but yeah. And what is negative 10 times 2 times 2 times 2? Negative 8. Okay. Do you have a question?
What does applicable mean?
When it applies, when there is an n. Yeah. When there's an n. So like in this next one, there's no n, so there's nothing to plug 2 in for. So this rule here doesn't apply. It's not applicable. Have you ever seen on a form or like a quiz NA? That means not applicable. It means it doesn't apply to the situation. Okay? Look at us learning all across sorts of disciplines. I should have been observed. Okay, 3 to the 4th. Coefficient, base, exponents. Which one would you like to give me and what is it? Aiden. The exponent is 4. So underline that in blue. Him. The base is 3 because it's attached to the power. And we've ran out of things to underline here. What's the coefficient? Technically it's a 1, right? Because we could write this as 1 times 3 to the 4th if we wanted to. Okay? But really, there isn't one. Whoops, now I just erased my. There isn't one. Okay? It's important to remember that a base can be a number, right? And it's almost trickier when it is because it's tempting. Some of you might in your head even be thinking 12. Thanks for not saying it, okay? But in expanded form, what this means is 3 times 3 times 3 times 3. It's repeated multiplication, multiplying 3 times itself. You don't put 2 because there's no n, right? You would put 2 when you have an n. There's no variable to plug in for here, so we're not going to plug it in. Okay, that's why it says when applicable. Not every expression has an n, therefore not every expression you'll be plugging something in. Okay, Aiden. We'll get there next. I want to finish this one first because what is 3 times 3 times 3 times 3? And if you give me an answer, explain to me how you could do it sans calculator. Sans means without a calculator. Evelyn. It's 81. And how could you get that without the use of a calculator?
3 times 3 is 9, 9 times 3 is 27, 27 times 2.
Okay, so you could just go straight across. 3 times 3 is 9, times 3 is 27, times 3 is 81. What's another option? Evan?
You could do 3 times 3 and like bring it down, and then 3 times 3.
Sure.
9 times 9.
Because you can multiply things in any order, you could make it a more basic fact by taking the 2 3s, each set of them, multiplying them to get 9, and then 9 times 9 is 81 as well. Is there a wrong way to do it? No. Okay, but having multiple options is always a good idea. All right, let's talk about one of the parentheses ones. Aiden, which one would you like?
6 and
Perfect. Now this one's a little bit trickier. Okay, the exponent is pretty obvious. The exponent in 6n, all of that cubed is what? 3. Okay. Now, what is the base of that 3? The 6n. The 6n is the base of that 3. What is the difference between 6n with parentheses cubed versus 2n to the 5th, where the 2 is not part of the base, versus negative 10n cubed, where the negative 10 is not part of the base? What makes 6 part of the base here, James?
Because you have to combine them because it's in the parentheses.
Because of
Term
order of operations. Parentheses have to come first. We don't know what 6 times n is, but because it's in parentheses, it lumps it together. That's what we're cubing. The parentheses song. I have an order of operations song. Just the perm dot song, yes. We're almost out of time though, so no. And so when you write this out in expanded form, it's not just 1 6. There are 3 of them. In expanded form, this is 6n times 6n times 6n. Okay? The parentheses make it so that there are 3 6s as well as n's. 6n, the whole thing, is the base. There is not a coefficient to this one either. So when you plug in 2 for n, you get 6 times 2 times 6 times 2 times 6 times 2. You could multiply each of those 6 times 2 to get 12 times 12 times 12. You could, what do you end up getting though? 1,728. Okay? So parentheses do make a difference. You need to pay attention to them. You'll see the difference parentheses make in these last 2 here, right? One of them has parentheses, the other one doesn't. How does that affect what you're going to do? Yeah?
I did different.
Okay?
I did 6 times 2 and then 12. Like,
Yeah, so I do want you to write it in expanded form, so I need the 6n times 6n times 6n. But what Tegan did was she replaced the n with the 2 still in the parentheses to get 12. Now you can do it first, right? And it becomes 12 cubed. Okay, because there are 3 6s there also. For homework, for tomorrow, the rest of this page, and does any fun await you? Yes, it does. Same thing on page 2. This time, not only might you have an N, you may also have a Y. Okay? And so when you plug, it's the same thing we did on the front. Exact same thing. Exact same thing. Okay? Then you've got some review at the bottom. We will review equations, arithmetic sequences, etc., etc. This is due for tomorrow. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Yes, James, you may use a calculator.
I'm not gonna get home until like 11.
I'm not gonna get home until
That's what he just said. Are you two hanging out?
No, we're going to a Vikings game.
Oh, do it at halftime. All those
I'm
TV
not even
timeouts,
going back.
you'd be like, you would get people to help you like around you. It'd be perfect.
Oh, I'm getting CMC to
You
help
should
me with
hold
my
a
math.
sign that says, "I'm here at the game, but my lousy math teacher gave me homework." I would approve that. I would approve that. All right, that's my math, folks.